All right, let's start talking through these. On part A, I have 49 to the power of 3 divided by 2. Whenever you see an exponent that's a fraction, what does that mean about it? How could I rewrite it?
The denominator is the index.
Yes, the denominator is the index. So whenever you see a fraction power, that's really a radical in disguise. So my index on this is a 2, which means it's what special kind of root? Square root, yes. It is a square root. So I'm going to have 49 underneath a square root. If you want to put the index there, you can, but if it's a square root, you're not required to put it there. What do I do with that numerator? Yes, put parentheses around it, and I keep that exponent there. Can we simplify the square root of 49? 7. So this is 7 to the power of 3. 7 to the power of 3 I can take and pop into my calculator, right? 343. Is that fully simplified now? Yes, I can't do any more to it. 343. Beautiful. Let's go look at part B. Do we have a fraction as our exponent? Yes. Which means it's really a radical, it's really a root. What is my index? 2 again.
But doesn't that mean there is no, what is this, something, that there wasn't an index before, or?
It means that I don't have to write the index down. If it's a 2, it's a square root, and you're not required to write that down. So this is a square root. Is there anything else that you notice that's interesting or unique about this particular fraction? There's a negative exponent. Are we allowed to have negative exponents? No.
No, flip it.
Flip it. We're going to flip it. No negative exponents. You with me, sir? So that means I'm going to have 1 over 64 to the 1/2 power. I don't flip my exponent fraction. I take my base, the big number, and that moves to the bottom of the fraction. Notice that when I do that, it's not negative anymore. All right, let's take care of that 1/2 part. We said that's the same as what kind of root? Square root. So 1 over the square root of 64. Do you guys know what the square root of 64 is? 8. So I can simplify this to 1 over 8. Can I simplify it any more than that? Nope. Final answer. So far, so good? Awesome. Let's go look at part 2, or number 2. What are we supposed to be finding on this? The value of x. Where is x? Under the square root. We want to figure out what that is. That means I can't put anything in the place of it. If I put something in the place of it, I'm saying I know what it is. I don't know what it is. I'm trying to find it. Are there any other variables in that equation right there, the same equation that has the x? There's an a. Anywhere else in this problem, do you see information about a? Yes. A is equal to 5 radical 2. When I have things that are equal, I can make an even exchange. It means they have the same value. It's like if you ask your friend, hey, do you got change for a 5? And they say, sure. Could they pull out 5 ones?
Yes.
Are you okay with that exchange? What about if they don't have 5 ones? They have 4 ones and 4 quarters. Yeah, that's an even exchange. When things are equal, we can make this even exchange. You can put one thing in the place of the other and switch them out. Let me know if you need anything else or if you need to go anywhere, okay? Yes, absolutely. All right, guys, let's pick this back up. I'm going to make a substitution. We're going to make an even exchange. What do we know that is the same size or same value as A? 5 radical 2. So I'm going to take that 5 radical 2, and it's going to take the place of the A right here. So I'm going to have 2, and then I'm going to put this inside parentheses. 5 radical 2 is equal to the square root of 2x. How do I multiply the 2 to the 5 radical 2? How do I do this? Distribute. Do I multiply this 2 by the 2 on the outside?
No.
Why not? Because it's not under a radical. So we're going to multiply the 2 and the 5 together. What's 2 times 5? So I'm going to have 10 radical 2 equals the square root of 2x. Where is x again? On the inside, under the radical. Somehow we got to get it out. I can't get it alone if it's under the radical. So somehow I have to figure out how to get rid of that square root. I know that addition undoes subtraction. I know that multiplication undoes division, and division undoes multiplication, but I'm not dealing with any of those operations. I'm dealing with a square root. How do I undo something that's been square rooted? No, because dividing undoes multiplication. I'm not dealing with multiplication, but good thought. I like where your brain was going with that one. To get rid of a radical, I'm going to use an exponent. Exponents, powers, make roots cancel out. Remember, roots are the denominators on fractional powers, and I want to get rid of that. What's the index on my square root? The index on my square root? No? What is the index on any square root? 2. I'm sorry, I thought I heard 7. I apologize. That was my hearing. The index is 2, and so that's the power that I'm going to raise it to. So I'm going to take this side, and I'm going to raise it to the power of 2. Rules of algebra say if you do it to one side, got to do it to the other side. Everything on the other side. So I put parentheses around both sides, and I raise both sides to the power of 2. Over on the right, my square and my square root cancel each other out. So I have just a 2x over here. What does it mean to square something? Times it by itself. So if I'm squaring 10 square root of 2, that means I have 10 square root of 2 times another 10 square root of 2. Oops. Yes. Let me bring this over here. 100 radical 4. We talked about how to multiply these together yesterday. The pieces on the outside get multiplied together. So I'm going to have 10 times 10, which gives me 100. And the parts that are under the radical get multiplied together. So I would have the square root of 4 right here. Do we know what the square root of 4 is? 2. So I'm going to have 100 times 2, which is 200. So I have 200 equals 2x. What do I do to figure out x?
Divide 2 from both sides.
Divide 2 from both sides, and that means that x is what?
100.
X is 100. Beautiful. All right. In your books, go to page 213. Page 213. The inverse of a quadratic function. What is a quadratic function? If I were to graph a quadratic function, what shape would it make?
A parabola.
A parabola. How can I tell from looking at an equation if something is a quadratic function? What will I always see? That would be on a table. What about just an equation? How can I know if I see y equals, like, I know if I see y equals mx plus b, I know that's a line. What's my tip-off that something's quadratic? X squared. Quadratic functions have x squared in them. What does inverse mean again? I told you guys every time we talk about inverses, what should pop into your head? Switch. Inverses undo other things. We just talked on the bell work about how to undo something that's been squared. How can I undo something that's been squared? Square root it. So the inverse of a quadratic function is a square root function. Is a quadratic function one-to-one? Do you guys remember when we talked about one-to-one? What'd you say, dear? I still can't hear you.
Don't you gotta see if it's a thing first?
See, yes, we got to see if it's a function first. Absolutely. What kind of visual test can I use to see if something is a function? Vertical line test for a function. Look at my parabola. If I take a vertical line across this parabola, does it cross in more than one spot at a time? Nope. So is it a function? Yes. Now that I know it's a function, I can check to see if it's one-to-one. What test do I use for that? Horizontal line test. Does it pass the horizontal line test? No. So is it one-to-one? No. It fails the horizontal line test. That means that there are at least two x's, or inputs, that have the same y, the same height, the same outputs. What we must do to a quadratic function so that the function is one-to-one. We are going to restrict the domain. What does domain mean? What are we talking about with the domain? The x's or the y's? The x's. What does restrict mean? To stop. What else? What does restrict mean? To prevent. think about the school computers, the school Chromebooks. Are you allowed to go anywhere on the internet that you want to? No. Stops you from doing certain things. Does it stop you from doing anything on the internet? No. There's some things you are allowed to do, and there's other things you're not allowed to do. Those are restrictions. Or if you think about at home, like you have restrictions at home. You have privileges. You're allowed to do certain things. You're not allowed to do other things. So when we say we're going to restrict the domain, we're going to restrict our x's. That means that some x's are okay, and some x's are not okay. If I can use some x's, but I can't use other x's, my domain will not be all real numbers anymore. So my domain is not negative infinity to positive infinity, because there's some x's that I can't have. We're going to look at those two graphs down below to learn how to restrict the domain. All right, look at those two graphs down there. In order to restrict the domain, we are going to cut the parabola in half at the axis of symmetry. And we are only going to keep the right half. So on the parabola, it's on the left, this one over here. How do I find the axis of symmetry? Yep. So it's going to go up and down. It's going to cut through the x-axis. What part of the parabola do I have to make sure to go through? Through the vertex. So right here. Where on the x-axis am I making that cut? At 1. And then I said we're only going to keep which side, the right or the left? We're going to keep the right side, so let's get rid of the left side. And then down here on this line, I'm going to explain algebraically where I made this cut and which side I kept. So since we're talking about the domain, I have to have an x. Where did I cut on the x-axis again? At 1. Did I keep the numbers that are bigger than 1 or smaller than 1? Bigger. What kind of an inequality can I use for bigger? Greater than. So I'm going to use greater than or equal to. I want you guys to practice with the second one on your own, and then we'll go over it together. Exactly what we did on the first one. Where would I make the cut on the second parabola? At -5. Yes, it's always going to have an or equal to sign with it. Good question. Always down the middle of it, yes. We always keep the right side. So you're always going to get rid of the left side. Always, always, always. So we're always going to use a greater than here because we're always keeping the numbers that are bigger than that. All right, so I'm going to have x. What kind of inequality do I want? Greater than or equal to. It's greater than or equal to what? -5. Beautiful. Beautiful, beautiful. Okay. Go down to the next problem, number 2. Find the inverse function. Ooh, we got to remember how to find inverses algebraically. What's our first step when we go to find an inverse function when I have a rule?
Don't you gotta switch it to y equals?
Yes, we're going to replace our function notation with y. So instead of p of x, I'm going to have y equals, and then x squared plus 3. We're going to switch the x and the y. So I'm going to have x equals y squared plus 3. After we switch x and y, what's the goal of the next step?
Get y by itself.
Get y by itself.
So subtract 3 from both sides, get x minus 3 equals y squared.
Yes. So I'm always thinking about order of operations. When we're trying to get something alone, we go backwards through the order of operations. This is to isolate, which is what we're doing. So we're going to subtract 3 from both sides, like you just said, Lauren. So I have x minus 3 equals y squared. Y is almost alone, but not quite. What's still there?
It's squared by.
It's squared. How do I get rid of something that's squared? Radical. With an index of what? 2. So I want a square root. So we're going to do a square root of both sides. Over on the right, the squared and the square root cancel each other out. And on the left, I leave it as the square root of x minus 3. Make sure that that square root symbol goes all the way over the x and the minus 3 part there. All the way over. So close to being done, it almost hurts. What's the very last thing I have to do?
You gotta put it back to p.
Yes. We will name our inverse.
But you leave the y out of it.
Yes. We're going to go back to the original function name. The original function name was p of x. So do I call this one p of x?
No, p of negative. Put a negative 9.
P with the little negative 1 of x is equal to the square root of x minus 3. There's my inverse. All right. Let's graph both of these. We're going to graph the original and the inverse here. This original function is a parabola. How has it been shifted? Up 3. So I'm going to make a table for this original function. So I'm going to have x's and y's. What are my 5 favorite x's?
Negative 2, negative 1, 0, 1.
-2, -1, 0, 1, and 2. To find my y's, what are we going to do to those? Square them. And then because it's been shifted up 3, I need to not just square them, but do what to them? Add 3. So what is negative 2 times itself? 4. So I have 4 plus 3, which gives me 7. And then I'm going to do the same thing to the next x. What is negative 1 times itself? 1. And then I have to add that 3, so I can shift it up 3. That gives me 4. 0 times itself? Plus 3. 3. And then what? And then it's going to repeat. So I'm going to have 1 plus 3 and 4 plus 3. So another 4 and another 7. Let's go plot those points. Negative 2, 7. It's going to be right up here. Negative 1, 4. 0, 3. 1, 4. And 2, 7. since I have this nice table for that function, how can I take that and get a table for my inverse function? Inverse means to do what? To flip, to switch. So everything that was down my y column is now going to go where? Down the x column. So what am I going to have down that x column?
5, 4, 3, like, yeah, y 4, 3.
7, 4, 3, 4, 7. What am I going to have down the y side? -2, -1, 0, 1, and 2. Let's go plot those points. -7, -2, 4, -1, 3, 0. Finish plotting these. Okay, so it should look like this right here. So here's our inverse. And here's our original. Is that inverse, the one that I did in red, is that a function? No. Why not? Yes, it does not pass the vertical line test. In order to make it a function, I have to make sure that any of my x's, if my x's repeat, they go to the same y each time. Is that true?
No.
Right now, it's not true. I have a 7 that goes to -2, and then I have a 7 here that goes to +2. Can't have that happen. So I have to get rid of one of them. I'm always going to get rid of the one that has the smaller y value. So 7, -2's got to go. On my original table, that means this would have to go. Are there any other x's that go to more than one y?
4.
4. I'm going to get rid of the one with the smaller y. That would be getting rid of this one off my original table. So I'm going to go mark out on the graph the parts that we just got rid of. On my inverse table, I got rid of the -1 and the -2 y's. On my original function, we got rid of the -1 and the -2 x's. That is restricting the domain. Does this red one pass the vertical line test now? Now it's a function. All right, we only have just a little bit of time. Turn the page. We're going to do one more practice problem where we algebraically find the inverse. We'll do a couple more tomorrow, but your homework that's due for me tomorrow morning has you practicing these. I want to look at part B because part A is really similar to the one that we already did. When I want to find an inverse, first step, what's the first thing I do? Yes. We're going to replace our function notation with y. So replace g of x with y. Yep, then we're going to switch our variables. So that means I would have x equals 9y squared. Divide by 9 on each side. So we're going to have x over 9 equals y squared. What next? Radical, square root. If you do it to one side, you do it to everything on the other side. So now I have y alone. When I take a square root of a fraction, that's the same thing as doing the square root of the numerator and the square root of the denominator. Do we know what the square root of x is? Do we know what the square root of 9 is? 3. So I have to leave it as the square root of x in my numerator, but down in my denominator I can rewrite that as 3. Last thing I want to do here. We're going to switch it to a g of x, but I want to make sure that everybody knows this is the inverse. So what little symbol? Little negative 1. G inverse of x is equal to the square root of x over 3. Beautiful, beautiful work, guys. Homework is due tomorrow morning. You get an unlimited number of attempts on it, so make note of the places where you have difficulties. We'll do some more practice problems with this tomorrow, and we will keep moving forward. Good work today, guys.